Hi. So today we're going to take a look at a method I have for making tuned coils. Now, back in the day, tuned coils were used a lot in the intermediate frequency stages, the RF stages, tuned gating, all sorts of different things for analog television, FM radio, AM radio, and everything between. Really, they're still used everywhere today. Specifically, these large tuned ferrite cord inductors. They essentially work by having a slug, a ferrite slug, that sits in this center portion here. And let me get this on here. And as you move the core closer or center pointed to the coil on here, it increases its inductance and its coupling to the rest of the transformer wherein the ferrite slug is located. So for instance, at this point here, the winding at this point will have the highest inductance and good coupling to this bobbin portion, this winding, but only half coupling, or only half of the winding width coupling over here on this winding. And if I move it back over here, we lose coupling. In fact, right now we're sitting at 0.22 millihenries, which is the air core inductance of this inductor. If I move this in, we can see it moves about, and we can get up to a maximum of an inductance of about 1.25 from a standing inductance of 0.22. So if you had, let's just say, an oscillator circuit, and you had a tuned capacitor, and you had a tuned inductor like this, you could make any frequency within the range of those two parts that you wanted, so long as the oscillator was able to operate at that frequency. This is pretty nice to be able to have. You could also use this, obviously, for signal conversion and modulation and things like that, wherein a feedback coil could be over here, and you vary the amount of feedback by moving this slug in and out. So that's pretty neat. And in this way, the way I have this printed, you can have 4 slots. This one came out rather poorly. You could have 2 slots like this, or you could have 3 slots like this one here, or this one here. You could also stack them if that was to be your purpose, keeping in mind that the cut of the ferrite should match the coupling of the next ferrite stage. So wherein you had these two here, in this case, you'd want this flat surface, not this chopped surface, to be in contact with this other portion here. If I have another ferrite slug, just pretend. Oh, you know what? I'll grab one. So there's our flat portion. Here's our chopped up portion. So we take the flat portion, we insert it. Our inductance goes up too, naturally, because it's in contact. If I bring it further over, remove contact, now this is almost like a fine adjustment on this side here as it gets closer and further away. And obviously this portion of the transformer would have different coupling as we adjust this to this portion of the transformer. So if you had a feedback over here and a feedback over here, there'd be less coupling between the two portions. And you can make transformer networks that do complicated tasks on signal analysis, mixing, injection, and things like that. Or even just automatic noise suppression by using phase cancellation between the two transformers, which is tuned in by a ferrite here. So yeah, you can stack them like this. Have our increase or decrease. Back in the day, they had these stacked on top of a steel chassis. You know, you'd have a steel chassis and they'd have a shield around it made of steel, or was it aluminum? No, I believe it was steel for the magnetic suppression. And you'd have a screw up top, and you'd adjust the screw, and the ferrite itself would be ridged and screw-like. I'm not fancy enough to have something like that, so it just sits in there with the tension from, you know, the 3D printed enclosure, because it's not perfect on the inside. If you were to actually implement this, you would take some wax and smush it back in there, and then you could move it in and out and just have that wax be the thing that keeps it in place. Or you could dab a bit of varnish on there, or even glue if you wanted, to after you get it fine-tuned in. You could, in theory, just create a carrier to move the ferrite in and out. But there you go. That's pretty much it. I'm going to be making more videos on transformers, but I wanted to go over this basic concept of its function in these tunable ferrite things, because I just got done 3D printing and they're pretty cool. These are actually just little pocket radio ferrite rods that I got on eBay. I think paid like, I don't know, $10. I got a box of them. I got like 50 of these things. Really cheap. And they're great for stuff like this. So, yeah, look forward to that. It's an important part of all sorts of analog modulation we'll be using in the future.